So, as I said, that I will be talking about application of AI for nutrition status assessment, how the application of AI is functioning in the field of nutrition science. So, since today we have mixed audience, I think we have audience from background other than the nutrition science and home science. So, I would slightly give a brief introduction of what I mean by nutrition status and its assessment. So when I say the term nutrition status, what does it mean? It means that it is the health condition of an individual or population resulting from the balance between nutrient intake or absorption and the body's nutrient requirement. We all know that whatever food we consume, it does contain certain nutrients and which has a direct impact on our nutrition status or the health status, right? Whenever there is some kind of, if there is a balance between the nutrient intake, then we are well nourished, we are healthy. But if there is any kind of imbalance between the nutrient intake as per the requirement of our body, it leads to malnourishment. And when I say the word malnourishment, it encompasses both undernourishment as well as overnourishment. So I have tried to make it as simple as possible so that it is comprehensive to all. Okay. So now it is important to assess the nutrition status, right? So to assess the nutrition status, normally in nutrition science, we follow ABCD approach, right? So A stands for anthropometric. Anthropometric means the physical variables, the height, weight, skin fold. On the basis of that, BMI is calculated. And then finally, we come to a conclusion whether a person is malnourished or is well nourished. The second approach of assessing the nutrition status is biochemical method, where we go for laboratory test. We can see the nutrient level in blood or urine. And the simple example, if we test, say, the hemoglobin level, that it indicates somewhere iron deficiency if it is less than the normal. So that is just an example. The third method of assessing the nutrition status is the clinical. C stands for clinical. Clinical means signs and symptoms which we can see of a deficiency. For example, if somebody has a spoon-shaped nails, we say, okay, the person is suffering from iron deficiency. Or if the person is not able to see in dark, less light, we can say, okay, maybe because of the vitamin A deficiency, night blindness can be there. So these are clinical. And the fourth method of assessing the nutrition status is the dietary assessment. So what we do, there are various methods of dietary assessing. The most common being the 24 recall method, wherein we just take the data from the participant in terms of the quantity and the quality of the food consumed. And on the basis of that, we calculate that how much nutrients they have consumed, and we compare it to the recommended dietary allowance just to see whether a person is well nourished or undernourished or overnourished. So now I hope you understand what is nutrition status and how traditionally we are measuring the nutrition status. Now, but these methods, they have certain limitations and challenges. The traditional ABCD methods, many a times, many methods, they are either time consuming, they are labor intensive, then there are chances of human errors while measuring something, there can be error. Then recall bias is one of the issues or the challenges of especially the dietary assessment, where the amount of food consumed by the person depends upon the recall of the person by the person. Then social desirability bias may be one, which means that many a times people tend to either underreport or overreport the things. For example, if I say as we know that junk food consumption or the ultra processed food consumption is harmful. So many a times when you go for dietary assessment, people may tend to underreport the consumption. So that may lead to a social desirability bias. Then the inter-observer variability, of course, person to person it varies, and few of the methods may be expensive, like the biochemical method. So keeping all these things in the mind, now it was felt, and with the introduction of the AI in the field of nutrition science, so AI in the nutrition assessment over the traditional methods, there are certain key needs was felt. What were these key needs? Like to overcome the inherent limitations of the traditional methods. Secondly, to improve the accuracy and the objective data collection. Then it is also needed for the real-time monitoring and the convenience. Then the scalability for the research and the clinical practices. So AI offers an automated, objective, and scalable solution that reduces the burden of the participants as well as experts, along with improving the accuracy. Now, let's talk about the introduction of artificial intelligence in the field of nutrition. As we all know that AI, it is a branch of computer science, which focus on developing the algorithms that simulate the human cognitive function. Though it is a fairly new field in the field of nutrition, but it is extremely important. And AI is reshaping nutrition and dietetics by advancing nutrition status assessment, personalized interventions, public health planning, and food innovations. So this is just a figure I have kept just to tell that various fields where AI is being introduced in the field of nutrition science, like the nutrition science and research, where we go for dietary assessment, food recognition, nutrigenomics, gut microbiome analysis, nutrient-drug interactions. Then in the case of food science, the process, food production, product development, food safety, quality control, in every sphere, the AI has been introduced. And similarly, in the public health nutrition, the various aspects like nutrition epidemiology, personalized nutrition and precision diet planning, nutrition education and intervention, food security and global nutrition. And in the case of diagnosis and treatment of disease risk prediction and early diagnosis, precision nutrition for disease management. These are the various fields where the AI has been introduced in the nutrition science. Now, today, since I will be focusing more on the nutrition status assessment, introduction of AI, application of AI in nutrition status assessment. And of the nutrition status assessment, I would be focusing more on dietary assessment and the anthropometric assessment. So these are the various spheres of when I say about dietary assessment, like the food image recognition, diet optimization, dietary pattern assessment, prediction of the risk factors, diet planning, and advancement. Now, coming to the major topic, that nutrition status assessment. This is the AI workflow in nutrition status assessment. Let's try to understand how the workflow happens, how it functions. The first step is the data collection. We have various type of data. It can be visual data, it can be the data obtained through the sensors, or it can be the EHR data, that is electronic health records. Once the data is collected, the data is processed. So data processing include various aspects like cleaning of the data, standardization of the data, extraction of the data. Cleaning of the data means that out of the various inputs, whatever are essential inputs that is required by the objective of the study, that is retained and rest is removed, and then it is standardized. The units are standardized that way, and finally we extract whatever is required. So that happens in the second step, that is data processing. Then the third step is AI analysis. Now the AI analyze the data which we have got, and then it is using various aspects like portion estimation of the food, say, or the nutrient estimation, or the risk prediction of the malnutrition or undernutrition. So that way the analysis point work. And finally, the fourth step is the decision support, which means that on the basis of the result which we have obtained, certain recommendations are made. It can be checked whether the goal which has been capped, which has been decided by us, the goal has been tracked, and even the early warnings in terms of undernutrition level or overnutrition, that kind of early warnings can also be received, right? So this is the workflow of AI in nutrition status assessment. Now, since I said that I would be focusing on two aspects, the dietary intake part and the anthropometric. So let's start with the first one, that how the AI for dietary intake assessment and nutrient tracking functions. So one of the most prominent application of AI in nutrition science lies in the dietary assessment and nutrient tracking, where AI is used to estimate the caloric and the nutritional intake based on the food images or the natural language input or the user interaction with the digital platform. And I've quoted few examples, like there are apps like GoFood 2.0, EfficientNet, Nutrify AI, which functions for the dietary intake assessment. Now, let's understand how the dietary intake assessment is done with the help of AI. So it has 5 steps. First of all, the first step is identifying the images with the food. right? Then identify the food. Then separating the food into separate parts. Then estimating the portion size which is served and the remaining, just to minus it, and then to estimate the amount of food that has been intake. And finally, on the basis of the amount of the food, when it is quantified, then the nutrient intake is estimated. So this is the workflow. Now, one by one, we will discuss about it. The first step I said that identifying images with food. So let's understand which AI models actually function with it. So AI models used to identify images of food, primarily they rely on the computer vision and deep learning. AI models, particularly convolutional neural networks, CNN, participant, kindly mute yourself. Thank you. So AI models, particularly is like CNN, they are widely used for recognizing the presence of food in the images. And the app, which is the real app, which are working and functioning, they are like the YOLO app or the Food 101. Now, the second step, as I said, it is the identification of the food. Here, the food is recognized and it is classified as, the food is classified as food items. And what techniques are used? AI techniques such as the support vector machines and the deep learning models, including generative adversarial networks and advanced CNN, they are used to identify the food. Now, coming to the third step, now separating the food into separate parts. Segmenting individual food items within an image is crucial for accurate portion size estimation. So that is very important. If we have to know that what is the amount of food, quantity of the food that is consumed. So first, it is important that in the whole plate, the food items are segmented. And for this, certain techniques like image segmentation using DNN, that is deep neural networks, they have been effective in this regard. Then after the food is segmented, now the portion sizes are estimated. Whatever portion is served and whatever is left, if you subtract that, the remaining is that which is consumed by an individual. So estimating the portion size of served and remaining food, it requires precision, volume, and area measurements. And the AI models using RGBD, that is red, green, blue depth imagery, they have shown promise in improving the precision of such estimation by using the depth information to enhance the accuracy of food volume assessment. And once we have estimated the quantity of the food, finally, now the nutrient intake are estimated. And this is the final step. It involves estimating the nutrient intake based on the identified and quantified, both. First, it is identified food item and then it is quantified. So, on the basis of the nutritional database to map the food items to their nutrition profile. So, the integration of AI for this purpose is exemplified by the system like the S2NI platform, which combines speech recognition and natural language processing to monitor the dietary composition from the spoken data, achieving high accuracy in the nutrient composition. So that was the theoretical part, how the dietary assessment is done with the help of AI. Now, I have also introduced few examples, few apps, real apps, which are functioning in this field. See, this is developed by Dalclety 2022, and you can see just it's a flow diagram for better understanding. See, this is an image which shows different food in a plate, right? So first this image is taken and this image is pre-processed. Once the processing is done, then it is segmented, as I said, that separate the parts, different parts. For example, here you can see like the chicken is separated, and the tomatoes are different and the vegetables can be seen and a bowl of rice is seen. So that way the features are extracted, right? And then dimensionality reduction. Again, dimension reduction means that whatever variables, whatever are required, that are retained and rest the extras or the other data are removed for more accuracy. And finally, we classify this food. And you can see then the portion size is estimated, the volume is estimated, for example, 60 gram of this, 100 gram of this, 200 gram of this. And finally, with the help of machine learning, now on the basis of the database, the nutrients are estimated So it comes like chicken, it contains 178 calories, rice is 129 calories, and vegetable is 128 calories. So traditional method, when we go for like on the recall basis, we take the quantity and the type of food, then we either on the laboratory basis or on the basis of computation, then we calculate, estimate. So this is much easier. One more example you can see for this dietary assessment using AI. This is an diet engine which is developed by SART et al. 2025. As you can see, first we have user input food image, that is the food image is taken, right? Then simply the device camera, it captures the image of the food. Now this image is being processed. Now if the processing fails, then it displays the error message. And if the processing is successful, then the feed image into the CNN model for further classification of the food item. Now the classification is done, right? Classifying the food items. Now, if the classification is not successful, then it will show a display classification error. And on the other hand, if the classification of the food is successful, yes, then we retrieve the nutrition information, we generate the nutrition report, and this app, it displays the nutritional report. Now, this in this AI app, this diet engine, it has one more additional feature other than the estimation of nutrient intake, is that now it checks the dietary preference and the restriction of the user, right? So if the preference and the restrictions do not match, then it requests the user to update the preference. And once the preferences are updated and the preference and restrictions are matched, then the food recommendations are generated, and finally the food is displayed. So it helps more, the secondary feature helps more in the personalized dietary assessment and recommendation. Okay. So to better understand, finally, this is an image. I think this will help you in understanding it better. This is an AI-based food image recognition system. You see, now, simple. First step, you can see the image is captured with the help of a camera or with the help of mobile app, whatsoever, smartphone camera. So this is the input of the food image, right? Then second, now the image is pre-processed. Pre-processed in terms of resizing, normalizing, enhancing, noise reduction. Now, noise reduction means the quality of the picture, the color of the picture, the contrast of the picture, the hues, which may lightening, which may otherwise affected. So on the basis of that, the image are pre-processed, and we get an output as a pre-processed image. When once it is adjusted, we get output as pre-processed image. So, okay. Now, once we get this pre-processed image, now it moves to the next level where the food detection happens and the segmentation of the food items happen in the image. As you can see, now it can detect and segment the food, like it has 4 type of food, and you can see the output is different food items are detected with the help of this. Finally, then next, the food is recognized. AI model, it classifies each food item, and in output, now we have got the recognized food items as rice, chicken curry, salad, mixed vegetable, and tomato. So we have these all items in this, and now the AI model, it has classified each of the food item. Now, once the food items are identified, it goes for the portion estimation. So now the quantity of each item is estimated. So once it is estimated, then we get, like, you can see the output in form of like rice is 150 grams, chicken curry is 150 grams, salad is 75 grams, mixed vegetable is 75 grams, tomato 2 slices, which comes to 30 grams. So it has properly estimated each and every food item which has been put on the plate, or the which is the in the pre-processed image. So now we have got the quantity. So now the 6th step goes for the nutrition analysis. Now here we calculate the nutrient content using the food composition databases, right? And now we get the output in form of nutrient information per meal, that how much energy it has. Like, say, in this example, it is given 650 kilocalories, carbohydrate 85 grams, protein 28 grams, fat is 20, and fiber is 6 grams. Now we have got the nutrient information. And then finally, we have the output and the feedback. Here we provide the results and the personalized feedback to the user. in form of like the nutrient summary, what amount has been consumed, what nutrients has been taken, the health insights, the suggestions can be given, the goal tracking can be followed, right? And for whole process for this food image recognition system, the technologies, the AI technologies which are used are the computer vision, because when we capture the image, so we use the computer vision tool where the image is enhanced, object detected, and segmented. Then with the help of deep learning, that is CNN, the features are extracted and the food is classified. Then the regression model, with the help of the regression models, the portion sizes are estimated. And finally, with the help of the food composition databases, the nutrient lookup and calculations are done. Then the machine learning algorithm, it helps in prediction, optimization, and personalization. And with the help of cloud and mobile technologies, the real-time processing and the user access is provided. So with the help of this, the dietary assessment technique, not only the diet tracking, it has an app, the application is for diet tracking app, but even for the clinical nutrition assessment, weight management programs, chronic disease management, public health and research. So this method, this dietary assessment method is applicable to so many spheres. And as you can see the benefits, we will talk about the challenges and benefits also later on, but the benefits are like, it is quite fast and non-intrusive as compared to the traditional dietary assessment method. Then it can reduce the manual entry, that is manual logging of the data. Then more accurate portion estimation is there, personalized nutrition insights can be given, and real-time monitoring is happening. That is also important, and this can support the healthy eating habit. So this is how the AI-based food image recognition system functions. Now, we just now what we discussed was that how we capture the image of the food with the help of smart camera or the smartphone, and then we estimate the dietary assessment. There is one more method of assessing the dietary assessment, is doing the dietary assessment with the help of AI. That is AI in the wearable devices for dietary assessment. See, AI in the wearable devices revolutionizes dietary assessment by replacing manual logging with automated real-time monitoring. So the traditional methods, as you can see, we go for manual logging. In the semi-automated, we had smartphone apps and cameras, etc. In the automated, we have smart objects. They can be smart utensils or the smart wearables. So what AI techniques like computer vision, deep learning, and sensor fusion wearables identify the food. The process is same. They identify the food, estimates the portion size, calculate the calorie of the nutrient intake via image recognition and the motion tracking. So you can see I have used two words, image recognition and the motion tracking, which means that even in these wearable devices or smart objects, they can be wearable or the smart utensils. In these smart objects, by two methods, the dietary assessment can be done. One can be the image, capturing of the image, and other is the non-image based dietary assessment. So I use two words, smart utensils and wearables, right? So these are just, you can see the pics of smart trays. You know, this is a restaurant where the dining hall is being converted into this AI facilitated smart dining hall. And here you can see a pic of smart plate where the food, the rest of the method is the same, which I discussed. The food is detected, and then the portion size is estimated, and finally the nutrient is calculated. Besides these, both there are so many smart utensils now, like we have the smart spoon, smart fork, smart bowl, smart plates, which help in dietary assessment. Here I have given example of this. These are the smart food utensils and eating devices. These use sensors and connectivity to automatically capture eating behavior and estimate the nutrient intake. So this first example, you can see the smart spoon or the smart fork. You can see the sensors are used here, right? So the sensors are in the here, and you can see the here you can see it can be the pressure or the weight sensors can be used, or the motion sensors can be used to detect the hand movement whenever we are lifting the smart spoon or the smart fork. And then there is vibration sensors which can detect the bite and the frequency. And once it can measure the number of bites a person is having, the eating speeds, the meal duration, and the portion size per bite. And it can then come in your screen, and you can tell whatever your bite count is there, what is the eating speed, what is the duration of the meal you have taken, how frequently you have eaten, that duration and timing, that is all, right? And this, the second example, you can see it is a smart plate and or a smart bowl, and you can see that it has built-in load cells, weight sensors are there. It measures the amount of food served and consumed. And again, the method is same, then it can be seen and can estimate the actual intake by calculating the difference between the food served and the food left. Now, let's understand how it works. See, these smart devices, spoon, fork, plate, what it does, the sensors over here, they capture the data. It can be the movement, it can be the weight, it can be the number of the bites. So whatever the input, that is the input for this device. And the data is then transmitted. Data is sent via Bluetooth or Wi-Fi to the mobile app where the data is processed. App or the cloud system process the data. AI image recognition identifies the food and estimate the nutrients. And when it is identified, then on the basis of that, the calories or the nutrient intake, they are calculated. And beside this, it also can see the eating behavior in terms of, as I said, like duration of the meals or the speed with which you are having or the bites you are taking. And finally, you get the feedback and monitoring. That is a real-time feedback. You are getting reports and alerts for healthy eating, and data is stored securely for the long-term monitoring and the research. So the advantages of this using the sensor-based smart objects is that objective and real-time data, reduce reliance on the memory and the manual food logging. As I said, so the chances of the bias or the recall bias will be reduced. It helps in not only like it can calculate your food consumption in terms of nutrient, but also it helps in the behavior modification, that is healthy eating or the mindful eating. And it is useful in the clinical nutrition, chronic disease management research, etc. However, it has certain limitations also. So in terms of like, it may be expensive and not widely available. They may not accurately identify all the food types. It requires user compliance and the proper usage. That is important. And the battery life and the technical issues many a times, that is also one of the limitations for not very much using the smart objects. So now that was with that we were taking the pics. Now I said non-image based AI dietary assessment. Till now we discussed the image based AI dietary assessment. Now non-image based. So when I say that non-image based AI dietary assessment, it can be categorized as three. It can be text based, it can be voice based, or it can be sensor based. So analyzing text based food records, processing speech for intake logging, and monitoring the variable senses for chewing, swallowing, and the wrist movement. So this is the basic fundamental approach. So what happens in the text-based dietary assessment? In text-based, the dietary logging is done, the daily food intake is recorded, and then NLP, that is natural language processing, it is used to interpret these entries. Then they identify the food item, estimate the portion size, and the nutrient content. See, Healthify Me, MyFitnessPal, you all might be aware of these apps. So they are functioning on base of the text-based, non-image-based AI dietary assessment. Now, so this was the text-based. In voice-based dietary assessment, simple. We use the AI tools such as chatbots and the virtual assistants, right? They utilize the speech recognition and then the natural language processing. With the help of that, it is interpreted the spoken dietary entries, and then it provides the immediate nutritional data, right? By the process same, by identifying the food items, its portion size, and finally the content. And this helped to reduce the burden of the manual logging. So third is the sensor based. When I say the non-image, earlier which we discussed, they were sensor based, but the image was taken. Now the AI algorithm analyze data from wearable sensors. Microphones are used which have acoustic sensors or accelerometers or the gyroscope. They are used to detect the eating occasions. For example, sensors on the neck, jaw motion, they can tell the jaw motion and the swallowing of the food. Or the sensor is in the wrist, then they can identify the eating activities, right? The motion is identified, and then it is tracked for the frequency and the timing of food consumption. So the motion sensor based tool, they help capture eating occasions through wrist movement, eating sounds, jaw motions, and swallowing. These functionalities capture the dietary data regarding the type of food or beverages consumed, calorie intake, portion size, frequency of eating, and shared eating occasions as real-time data, making it more accurate as against the conventional dietary assessment methods. So where are they can be applied? The applications of the motion sensor based tracking, like wearables such as smartwatches and wristbands. They use sensors to detect eating gestures, as I said, hand to mouth movement, jaw motion, swallowing sounds. And now simply these devices, they track when, where, and how often a person eats. So more of the personalized nutrition. And then applied can be for the real-time data and personalization. AI processes continuous inputs from the variables to provide personalized nutrition advice and identify the dietary patterns, allowing for the immediate feedback on the eating behavior. And third, it is also very much crucial for the chronic disease management. Wearable systems assist in tracking the dietary intake for individuals with metabolic conditions, say such as diabetes, by monitoring their food consumption alongside with the physical activity also they consume and along with the food consumption. And the very simple example is the bite counter. Now, this is how a bite counter looks like. She has worn it on her wrist. This is a wearable which is worn on the wrist, and it is a bite counter. It is a wearable device which is integrated with tri-axle accelerometer and gyroscope. It just appears as a clock and worn on the wrist to record the number of the bites that the user ingests during a meal. This information is extracted from the analysis of wrist torsional movement and the wrist movement occurring when the subject brings food from the plate to the mouth. So simple, if you don't go by the technical things, the simple thing is that started with the number of bites which is recorded during the meal, and equation calculates the total calories which has been ingested. An example of algorithm for detection of the number of bites coming from the data collected with an inertial sensor and a predictive equation to estimate the calorie consumed associated with a single bite. So you can see that in these sensors, we go for like the hand motion, the wrist motion, swallowing, masticating, that those sensors are working and they are not capturing any image, right? So that is why I use the term non-image based. Same, this was sensor based, same is for the text based when I said, where the text is lodged and then the processing is done, AI processing happens, and then the voice based, where we with the help of natural language processing, we do the entries with the spoken language. So in all these three, we don't need any kind of image. One more example you can see for this, as you see for the bite counter, this is one more example. This is an app which has been developed as I Eat wearable device by Liu et al. 2024. And these are the real apps, and they help. You can see this is a human food impedance model where the sensors are placed, and then the processing method is the same. So it is an automatic dietary monitoring can be done. The model enables non-invasive continuous tracking of the eating habits. The I Eat model can detect food activities, which can be like cutting, drinking, eating with utensils, and it has an accuracy of over 86%. And it can classify various foods like meat, bread, vegetables, and the counting. The system can estimate the number of the food item consumed with average counting error of almost 11.48. So this is an app which has been developed, I Eat wearable device by Liu et al. For dietary assessment. Okay, so this is one more example of the auto dietary app. It is an electronic device for food recognition based on the distinction between the chewing and the swallowing sounds produced while eating. The system is composed by a necklace which records sounds of mastication through acoustic sensors and a smartphone or a tablet application, which allows the data transmission and elaboration and gives the user an information of the food time. And you can see that can be, the sensors can be in the glasses and they can be in the neck or in the wrist. So these are a few examples. Now, it can be non-image based as we discussed, and it can be image based sensors also. So you can see it is one of the AI-enabled wearable camera for dietary assessment. This is developed by Liu et al. 2024. And you can see the passive monitoring system for dietary assessment. How it works, see the glasses, we have these cameras for the side views, and similarly we have this E button. It is a chest pin kind of device which is worn by attaching to the clothing, right? Just simply like the chest pin, and there's a camera which can take the image of the food in front of you. So the side view of the food and the front view of the food can be taken, and with the help of this, finally the rest of the steps are same. When the capture is imaged, with the image is captured with the help of computer vision, the data is transmitted, and then this data is processed, and the food recognition is done, and the portion size is estimated through the AI system. Then it generates the dietary reports as the dietitians. It can assist dietitians in conducting the dietary assessment, and then we get this. The report is generated. So this is how the AI-enabled wearable cameras work for dietary assessment. Okay, so this is one more example, that is E-button, and it is a wearable computer collecting and processing data about not only about diet but also for the physical activity. As you can see, because of its very small dimension weight, it can be worn on the chest, and it contains 2 wide-angle cameras similar to this. And there are certain technical things like it has a UV sensor which distinguishes indoor and outdoor games. It has an IMU which consists of accelerometer and gyroscope and magnetometer, audio processor, proximity sensors, and then distance of device floor and GPS. It can communicate wireless via Wi-Fi or Bluetooth. So, considering its use as a dietary device, e-button camera, it collects the images with a determined rate. These pictures are analyzed to determine the type of food that the user is eating through the techniques of the computer vision, as I already discussed. So first, shapes of the utensils are detected, then the food regions are segmented based on the color, texture, complexity measures. Next, the volume of each dish is determined with a comparison of the food-specific shape models. And once the food and the volume are detected, the calorie information is extracted from the database, like in this case, which they have developed this with the help of the food and nutrient database for dietary studies. So these are some real apps which has been developed for the dietary assessment based on the image or the non-image, right? So I hope it is clear by now that how it functions in the case of dietary assessment. So as I said that for the nutrition status assessment, I will be focusing on the 2 points. That is, one is the dietary assessment, which we have already talked about. Now I will be dealing with this, that how the application of AI is functioning in the case of anthropometric assessment. I have used the word malnutrition also because AI is also functioning detecting the malnutrition, because ultimately the aim of assessing the nutrition status is to find out whether the person is malnourished or well-nourished. So anthropometric, as I said, we know the height, weight, BMI, and the waist circumferences, and all those variables are taken. So the first is the computer vision for image-based assessment. What happens in this method? AI application in anthropometric measure, they transform the traditional manual method into automated, contact-free digital processes using 2D smartphone images or the 3D scanners. So either with the help of 2D smartphones or the 3D scanners, the images are taken and then the anthropometric assessment is done. AI algorithm analyze images or videos captured by the smartphone to estimate the anthropometric measurements. Mobile app allow patient to capture 2D images to estimate body weight, volume, BMI, etc. So AI-based image processing uses computer vision, as we already know that by now, and deep learning models to analyze the images or videos of the individual and extract the body measurements. Now, this system, what it does actually, it identifies the key body landmarks through pose estimation techniques to estimate various parameters. Key body landmarks through pose estimation techniques. Now, what all algorithms are used for this? AI uses algorithm like random forest or ANN to turn the photo to or the depth sensor data, that is the 3D, into precise measurement. For example, using Kinet V2. This is just an example technicalities. And these AI tools like the CNN, as I said, it accurately measures height, weight, girth for the health assessment. And few examples you can see as shape scale. It is a 3D scanner, fit 3D device. It is used for body composition, Me 360 mobile app. You all can refer to these examples. Okay. Now you try to understand with this how the AI-based image processing helps for anthropometric measurement. So I said pose estimation and key landmarks. That was the 2 words which I emphasized in the previous slide. Pose estimation and key landmarks in the case of anthropometric measurement. Now, see what happens. This is come to the first point. This is an input image of a person, right? Now, first what happens? The body is detected. It's a human body. It is detected. Now, the pose are estimated. What are pose? It is a computer vision technique that detects the human body and identifies the key points, that is the landmarks on it. Now, these points are connected to form a skeletal model. The measurement between these points are further used to estimate the anthropometric parameters. So the pose is estimated in the 3rd step. And finally, in the 4th, the key landmarks are seen. For example, the top of the head, the shoulder, chest, waist, hip, knee, ankle. So these are the key landmarks. And then on the basis of these key landmarks, the measurements are estimated. For example, the height can be estimated. It can be calculated from head to the foot length, right? The weight can be estimated, predicted using the height, body dimensions, and the ML models, machine learning models. With the help of that, the weight can be estimated. And on the basis of height and weight, the BMI is calculated. And many times the body portions like shoulder width, waist, hip, waist circumference, hip circumference, that can be measured, right? So what all technologies AI technologies are used? Deep learning, that is CNN basically, then the pose estimation for the pose estimation models, open pose, media pipe, MoveNet, etc. they are used. And with the help of computer vision libraries, the TensorFlow, Python, OpenCV, etc. they are used. And this way the anthropometric measurements are taken. So benefits are uses only smartphone camera and images. You don't have to take the steadiometer and the wing balance and then you take this now, and it is a non-invasive test also because it is contactless, and it is suitable for the large scale screening also, quick and real time, and it is cost effective also. So this is how the anthropometric measurement is done, and as I said, that anthropometric measurement is also one of the approach to see the malnutrition level, whether a person is malnourished or not. So AI enhances malnutrition assessment through computer vision, predictive analytics, and automated screening tool, which we just saw. Now, what happens? The key application include using facial or the body photographs to identify the child malnutrition, and along with the EHR-based prediction models, that is the electronic health records, and IoT-enabled monitoring, Internet of Things enabled monitoring. Machine learning models, for example, the random forest neural network, they're integrated into the electronic health records to analyze the clinical lab and the demographic data. So you can even, if you want to see any correlation with these things, the electronic health record, like the age, gender, like that also, that can be, with the demographic data also, it can be correlated. And these models provide automated risk scoring for malnutrition, and they can even alert the clinicians to address patients. So this is how it functions. And one of the example, which is this is by Timsna et al. 2021, the reference. This is machine learning based MUST Plus, that is malnutrition universal screening tool, is developed, which provides superior performance in identifying malnutrition. This tool can be used for improving the operational efficiency of the registered dietitians by timely referral of the high risk patients. Now, we'll understand through this also how it happens. See, first, machine learning pipeline जो अभी हमने बोला था at the last. So how it functions actually? The data is collected, all the data, like we have now height, weight, BMI, MUC, all with the help of images of the 3D scan videos. We also have the EHR data in form of the demographic details and the lifestyle data. Now this data is processed, and pre-processing of the data happens where the goes for data cleaning, handling missing values, standardization, etc., etc. Once the pre-processing is done, now we go for the exploratory data analysis, where the visualized data distribution is there, correlation analysis is there, and then the identify the pattern and the important features. Now, model is selected, choose appropriate machine learning algorithm. It can be linear regression, random forest, SVM, KNN, neural network. It depends what kind of requirement is there. Accordingly, the model is selected. It is trained, model is optimized model parameters, and then it is evaluated, right? Evaluate the performance using metrics. And finally, on the basis of this model training and model evaluation, the predictions are done. You can predict the nutrition status, whether a person is undernourished or normal or overweight or obese. The reports can be generated, visualization can be there, and you can deploy model in app, web, clinical system for real-time use. So how it works, as you by now you all understand how it is working. There is raw data, measurements, images, demographic. These all function as the inputs of the raw data, which are pre-processed. Once we get the pre-processed data, the pattern recovery is seen, modern learning is done, prediction, and finally, the nutrition status is assessed, and then you can make the decision accordingly. The advice can be given. Now, so the inputs are very clear, and what are the outputs? It can be the BMI prediction, malnutrition risk can be, you can estimate whether a person is in malnutrition risk, growth status, whether a person is stunted, normal overweight, that can be in obesity risk categories, and also the personalized nutrition recommendations can be made on this basis. The benefits are that it is high accuracy with consistency, it can handle the large data set efficiently, it can help for early detection of the nutritional issues. Personalized insights, it is cost effective and time saving, and it can be scalable for the population and the public health issues. Now, so that is how the mechanism of the functioning. And now we'll take some real examples for better understanding, as we took in the case of dietary assessment. Now, this is a child growth monitoring. It is a specialized AI tool, which is known as LWI, that can measure child length and weight from images that can be taken by the parents at home. So what it helps? It helps in reducing the need of the clinical visit and the specialized equipment if a person is in some remote areas, inaccessible areas. So this can help to some extent. So how this Lavai tool it works? It is length weight artificial intelligence tool. It has been developed by Janadal in 2025. So this tool can predict length and weight of child who is less than or equal to 18 months. It is only functional for to detect the child malnutrition or child who is 18 months old. And it offers a practical, convenient, artificial intelligence powered alternative for growth monitoring in home as well as in the clinical settings. What happens? As simple as that, images are uploaded and processed by the LWI algorithm. The reference detection and the segmentation model converts pixel to the size based on the known dimension of the reference card. Simultaneously, the body landmark extracted model identifies the key body landmark as we just saw it in the previous slide, and this can predict the body segment, length and weight. And so we know by this that the system also generates warning signals for the images that do not meet the criteria for the accurate length and weight estimation. So this is how it is happening. You can see this is child, and there are certain specifications like the child should be tightly dressed, and there should be not on any kind of obstruction from other objects. There should be a good contrast with the child in the background. The light should be brightly lit, and the picture should be taken from vertical down, not from any angle. So these are certain specifications for this app. But finally, it helps to tell us the that what is the height and weight of the child, and whether classify further whether the child is malnourished or is at risk of malnutrition, and immediately that kind of healthcare can be provided. See, this is one more where this can be specifically used in our Anganwadis also. In the morning, ma'am was talking about AI in the child health. So the AI in the growth monitoring can be used, where AI can be used as an alert system. See, you can see, for example, if we have a child in, say, in the Anganwadi, and we, as we know that we have their monthly data with us in terms of weight, height, and then we can predict on the basis of this, say the wearable devices, health worker records. On the basis of this, the AI alert can be generated whether a child is at high risk. In this case, we see the monthly records. So we can see that the child weight is below -2 SD as compared to WHO, and it has a high risk of undernutrition is detected. And therefore, the alert and alarm can be given that if there is a need of nutrition intervention, and follow-up can be recommended. And such kind of automated alerts can be sent to not only the health workers and the nutrition supervisors, but also to the parents and the caregivers. So the key benefits of this alarm system is that early detection of the growth,
Sorry to interrupt. In the background, there is some sound now, noise. So please mute participants.
And so, after Saturday, Sunday,
participants, it is a humble request to kindly mute yourself, please. Thank you. Okay, so these are the key benefits of the AI in the growth monitoring. So this is one more example where it can use like this. Now, one more example, real app. It is Miron. That is method for extremely rapid observation of the nutrition status, computer vision, and the facial recognition. It uses the smartphone images to identify the child malnutrition by analyzing the facial features and
Please mute yourself because it is not recognizable who is speaking.
Lunch में आप ना
Srishti can mute.
Yes, ma'am, I tried that option, but that particular person is already muted. I'm muted before, so that person can't be muted right now.
Okay. So, as I said, that one more app is this Miron, that is method for extremely rapid observation of the nutrition status. What it uses? It uses the facial photos to classify the nutrition status of the child and adult BMI also, and it is useful in the case of emergencies or the conflict zones or the pandemics. There it can be very useful. And you can see this how it functions. It has 3 models. Miron model, it is an AI tool for detection of the acute malnutrition in children. It has 3 distinct models to predict malnutrition. The first model, you can see, it is a face alignment. Here it uses VGG face-based architecture to extract the encoded facial features for the detection of the acute malnutrition in the children. Now, in the second model, it reduces the dimensionality of the feature vectors using an autoencoder. I said the dimension reduction is important. And then Here the metadata like the age, gender, and other demographic details can be input at this stage. And in the third model, it is fully connected neural network, which applies a trainable neural network layer to predict the malnutrition status through a classification model and WZ score, which we have. So through a regression model, we get the output whether the child is malnourished. And this Miron model, it has been developed by Watkins et al. 2024 for detection of the acute malnutrition in children. So AIMM, that is artificial intelligence for monitoring malnutrition, it is an open source AI powered mobile application which is designed to improve child nutrition monitoring by estimating key anthropometric indicators from 2D and the infrared images. It provides a low cost, non-invasive and real-time information. It utilizes computer vision, machine learning to analyze images for body segmentation and measurements. It is designed to work with both standard 2D photos and infrared image to maintain the privacy. Domain adapt, so it is important to talk about this framework also. This was developed by IIT and AIIMS Jodhpur in collaboration with this to make malnutrition screening more efficient, accessible, and scalable. So this domain adapt, it is a novel artificial intelligence framework developed to automate childhood nutrition status assessment, designed for use in public health context, particularly in the resource constrained environment. What it does, it utilizes a multitask learning framework that incorporates a novel dynamic task weighing method. So this method balances task-specific losses by leveraging the domain knowledge and mutual information, allowing the model to improve accuracy in predicting the anthropometric measurements like height, weight, MUAC. So this I am trying to give some real models examples so that for better understanding. And yes, this is one app that is Shishu Mapan, and it is designed for frontline workers. Ma'am was also talking about this in the first lecture today, the keynote speaker. So by Vadhwani AI, this is developed. What it is the AI-enabled solution allows to capture accurate measurement of the newborn, such as weight, height, head and chest circumference, using only a basic smartphone. Shishu Mapan, as the name says, it can accurately measure the anthropometric data of newborn, say 0 to 42 days, from a short videos that is taken on a basic smartphone in a community setting. So the frontline worker captures the newborn video using a basic smartphone. The AI model then estimates the anthropometric measurements and generates accurate real-time and tamper-proof measurements. So you can see that how AI is functioning in the field of anthropometric assessment, ranging from the adults to the children and even to the newborns. Okay. Besides this, wearables and IoT-enabled bioimpedance scales are also there for the anthropometric measurements, as we saw in the case of dietary assessment. Similar, it is for the anthropometric measurement also, where wearables and IoT-enabled bioimpedance scale, it is integrated with the machine learning models. It provides real-time monitoring of the body composition and nutrition status. For example, we have smartwatches, smart scales, bioimpedance sensors, smart clothing. So this AI integrated data can be analyzed to provide the personalized diet recommendation, detect potential healthy risks. About smartwatches, smart scales, you all know. A bioimpedance sensor, just quickly I'll tell, as I think I'm running out short of the time. So bioimpedance sensors, how it works, you can see the sensors are here. The sensors are set up, electrodes are placed on the body surface, right? And then a small alternating current, which is very safe and painless, it is passed through the body. Now, depending upon the body tissues, the electric current passes, as you all know, that is the impedance. And on the basis of that, the sensor, they measure the voltage and current. On the basis of that, the impedance is calculated. On the basis of the impedance value, along with all the personal data we have, it is using predictive equations to estimate the body composition. And on the basis of that, we can calculate the body weight, body fat percentage, fat mass, lean mass, muscle mass, total body water, BMI, basal motor modality, visceral fat level. So these are type of the impedance measurements are taken. And how it works, as you can know, that AC current is going, tissues resist the current, sensor measures it, impedance is calculated, and on the basis of the equation, it is calculated, right? So at last, I would like to tell advantages. By now, you all know the advantages of the application of AI in the nutrition status assessment. It is speedy, it is accessible, it is non-invasive, it can enhance the precision, it can improve early detection, so that we can provide the nutrition support on time and for a better patient outcomes. Many of the apps, they are very cost-effective, time-saving, and reduce labor. Then real-time monitoring, that is one of the very important feature of application of AI. Personalization, we have tailored diet recommendations can be given, and it can be done on the large-scale application. But we have limitations also for the use of the AI. the most important is the lack of the real world usage. Actually, over 90% of AI models for malnutrition, they go unused because still we are in the pilot stage and it is not widely implemented. So that is one of the limitations. Then certain challenges are there, like data privacy is one of the challenge when we have used the image or the personal data. So it raises the privacy concern. That is one of the issue. Generalization standardization, because many of times, as I say, when we depend on the computer vision, we need proper lighting, image quality, lack of the standardized data. We need large food database. So that is one of the issues. So it requires further validation and standardization. Still, it needs, we are in the infancy stage, you can say. Then over-reliance, many a times over-reliance on these apps, they may impact the human expertise to some extent. Technological infrastructure is one of the issues, because in many places, you can't use such costly equipments because some equipments are actually costly. And data bias and lack of diversity, because aside that, we have less database still in terms of not only the anthropometric database, but also dietary database. For example, if there is a, you can say, some traditional food items, they are still not categorized, they are still not sterilized. So that can, it will not read that. Similarly, if there is an ethnicity there, if we go for, say, anthropometric measurement, so ethnicity can be an issue because it depends upon the database we have. So it's working efficiently, accurately, that is there, but still we have long way to go, and we have large scope of improvement. So that is all from my end. These are certain reference. Thank you all. Thank you for patience listening.